Good morning, students. In the previous class, what had to be learned? Electric charges and Coulomb's law and their properties and the difference between the Coulomb's law and the gravitation law. So today we will be discuss about the electric field and electric dipole. Okay, electric field lines and electric dipole. So first, what is electric field? What is electric field? Field is nothing but some invisible layer will be present between the two charges. Coulomb considered the two charges as separated at a distance. So, two charges and positive charge and negative charge will be separated at a distance. One force will be created, that the force of attraction is between the two forces. Coulombs will be discussed in the previous classes. So, at the action of distance between the two charges, how will you find out the second charge? How to know the existence of the first charge? So, some invisible layer will be presented between the two charges, that is called electric field. Electric field is nothing but some field, it will be invisible, it will be presented at the two charges, that is called electric field. So, how will you calculate the formula for the electric field? Electric field E is equal to F by unit charge, F by touch charge. What is F? What is the formula for force, Coulomb force? That is Q1 Q2 by R square, that is K into Q1 Q2 by R square and R cap is a unit vector. So just put into this formula 1 by 4 pi epsilon naught, K value is 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught Q1 Q2 by R square. Q1 Q2 you have to consider as one charge and another one is test charge. So Q naught by R square and by Q naught. So Q naught cancel. So 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught Q by R square into R cap. That is the formula for electric field. How did you calculate? So electric field E is equal to force by test charge. So what's the formula for force? Q1 Q2, you have to consider Q1 as a charge, one of the point charge, and Q2 is the test charge. So Q naught by R square and R vector, R cap, then by Q naught cancel, 1 by 4 pi epsilon naught Q by R square into R cap. This is the formula for electric field. What's the unit of electric field? Unit of electric field, force by charge. What's the unit of force? That is Newton. What's the unit of charge? That is Coulomb. So unit of electric field is Newton per Coulomb. Unit of electric field is Newton per Coulomb. So what is electric field? The field will be present in the two charges, that will be invisible, and then the electric field is equal to force by test charge, and substitute the force formula and then divided by the test charge, 1 by 4 by epsilon naught Q by R square. Then this is the formula for electric field. What is the unit of electric field? That is Newton per Coulomb. Okay. Next we will discuss important aspects of electric field. Important aspects of electric field. Important points are important aspects of electric field. Important aspects of electric field. What first one is, suppose you have to consider as a positive charge. The electric field is moves away from the charge. Then suppose you have to consider as a negative charge, electric field is moves towards to the charge. First one is, suppose you have to consider as a positive charge, electric field is moves away from the charge. Suppose you consider the negative charge, electric field is moves towards to the charge. And second one, what's the formula for electric field? E vector is equal to F by Q naught. So you have to calculate the force formula. F, it will be equal to E vector dot Q naught. So force is equal to U multiplication of electric field and test charge. And third one is electric field is independent of charge. It's independent of test charge. Independent of test charge Q naught. Test charge Q naught. What's the meaning that F by Q naught? So Q naught Q dot cancel ஆகிறதுனால electric field is independent of test charge Q naught and will depend upon the charge Q. Dependent upon the charge Q. Point charge. Depend upon the point charge Q. So, third one is electric field is independent of test charge and dependent upon the point charge. First one is electric positive charge. Electric field is moves away from the source. Negative charge, electric field is moves towards to the source. Second point, electric field is equal to F by Q naught. So, F is equal to E vector dot Q naught. And electric field is independent of test charge and electric field is dependent upon the point charge. And fourth point, electric field is a vector quantity. Electric field is a vector quantity. Electric field is a vector quantity. And then fifth point is electric field, it will be inversely proportional to the square of the distance. Electric field is inversely proportional to the square of the distance. What's the meaning that distance will be increases, distance between the two charges will be increases, electric field will be decreases. Difference between the distance will be increases, electric field will be decreases. That I will give one example for that this point. You have to consider one charge and that is considered as a point P, that considered as a point Q, that's a considered as a point as R. So that the point Q point comparable to P and R, electric field will be strong. Electric field is strong. Why? It will be very close near to the charge. So the electric field is very strong. The distance will be decreases. Electric field it will be strong. Okay. And then so fifth point is electric field is inversely proportional to the square of the distance between them. Distance increases and electric field will be decreases. And sixth point, test charge it will be very small. Test charge Q naught is very small. Cannot modify the point charge. What's the meaning that first point charge is Q and test charge is Q naught. It is very small. It is ரொம்ப small இருந்துச்சுனா இத எப்படி modify பண்ண முடியும்? So it will be very small. So it cannot modify the point charge. So Q naught is very small. Cannot modify the point charge. Cannot modify the point charge. Cannot modify the point charge. So fourth one is electric field is a vector quantity. Electric field will be inversely proportional to the square of the distance between them. Q naught is very small, cannot modify the point charge. And so electric field expression is only valid for point charge. Electric field expression, what is the electric field expression? E vector is equal to 1 by 4 pi epsilon naught Q by R square. This formula is, this expression is only valid for point charge. But other some of the all the charges will be become, so you have to calculate in the integration format. It will be in the limit formation. So integration format you actually used to you have to consider as a lot of charges. So this expression is only applicable for point charge. So you have to consider all the charges in the system. You have to use the integration method. Okay. So these all are the points of the electric field. And electric field vectors, electric field nothing but is some lines will be formed, that is will be discussed with the electric field lines. So first go for the next topic, the important aspects of electric field. Then second one, electric field due to system of charges. Electric field due to system of charges. Suppose consider one system having lot of charges E1, E2, E3, something like that. You have to, how will you calculate the electric field? So electric field, total electric field E vector is equal to E1 vector plus E2 vector plus E3 vector up to that En vector. So one system having lot of charges, first E1 vector, E2 vector, E3 vector up to that En. So by using the superposition principle, according to a superposition principle, sum of all the charges get the total charge. So E1, E2, E3 up to that En. So you substitute the formula for E vector 1 by 4 pi epsilon naught Q by Q1 by 1 by 4 pi epsilon naught Q1 by R1p square, Q2 by R2p square, so Q3 by R3p square up to that. So electric field, total electric field is equal to sum of all the electric fields for all the charges. So 1 by 4 pi epsilon naught Q by 1 R1p square, Q2 by R2p square, Q3 by R3p square up to that. Then this is the formula for, you have to simplify this 1 by 4 pi epsilon naught summation of I is equal to 1 to n Qi Rip square. Then you have to include the unit vectors for all R1p vector, R2p vector and R3p vector. So as well as Rip cap. So this is a simplified expression form 1 by 4 pi epsilon naught summation of I is equal to 1 to n Qi Rip square and Rip. This is the expression for system of charges, and go for the continuous charge distribution. Electric field due to continuous charge distribution. Electric field due to continuous charge distribution. Continuous charge distribution. Continuous charge distribution, you have to consider as one charge, you have to consider some segments. Segments means elements. Elements, you by using the limit formation, you have to mention the continuous charge distribution. First, you have to consider the electric field E vector is equal to 1 by 4 pi epsilon naught del Qi by Ri square. This is the way you have to use the continuous charge distribution. So Qi1 R1p square plus 1 by 4 pi epsilon naught del Q2 by R2p square up to that. So in the simplified form, summation I is equal to 1 to n del Qi by Rip square, then Rip cap also. So this is the continuous charge distribution. Del is some little bit value. Del ஏன் யூஸ் பண்ணோம் அப்படின்னா ஒரு சின்ன சின்ன செக்மெண்ட்டாக பிரிச்சிருக்கனால டெல்னு யூஸ் பண்ணுறோம். திஸ் இஸ் த லிமிட் ஃபார்ம். இது வந்து லிமிட் ஃபார்மில் மென்ஷன் பண்ணியிருக்கோம். ஸோ 1 by 4 pi epsilon naught is in there in the previous. So 1 by 4 pi epsilon naught summation of I is equal to 1 to n del Qi by Rip R1p square and Rip vector. So this is the limit form. லிமிட் ஃபார்மில் இந்த மாதிரி ஃபார்முலா எழுதியிருக்காங்க. இது என்ன பண்ணியிருக்கோம் அப்படின்னா சார்ஜை சின்ன சின்ன செக்மெண்ட்டாக பிரித்து அதுக்கு ஃபார்முலா எழுதியிருக்கோம். ஓகேவா? இதே சார்ஜுக்கு இன்டகிரேஷன் ஃபார்மேட் நீங்கள் யூஸ் பண்ணிங்க அப்படின்னா 1 by 4 pi epsilon naught summation எழுதக்கூடாது, integration of dq by Ri square. This is the formula for electric field, total electric field for charge distribution, continuous charge distribution. So charge distribution, in the various way the charge will be distributed in the linear, surface or volume, just like that. I will give the formula for linear density, surface density and volume density. So go for the next one. Formula is there. First you have to calculate linear charge density. Linear charge density. What's the meaning that linear charge density? Charge density means charges எங்கே அதிகமாக இருக்குதோ அதான் charge density. Linear charge density means linearly one metal scale having more and more charges. So number of charges by unit length, that is charge density. Number of charges by unit length is linear charge density. So you put the value for dq. So linear charge density denoted as lambda Linear charge density is denoted as lambda charge by unit length. So, linear charge density is lambda is equal to q by unit length. So, you have to calculate d lambda is equal to q by dl. Q we mentioned, and so q is equal to d lambda by linear charge density lambda is equal to q by L. So, lambda L is equal to q. So, in the integration format, lambda into dl is equal to dq. You substitute the dq value for this equation. Electric field E is equal to 1 by 4 pi epsilon r. dq value is integration of lambda into dl by r square. That is, linearly the charge is distributed in the one system. You have to calculate the electric field E is equal to 1 by 4 pi epsilon naught integration of lambda L by r square. This is the formula for linear charge density. This is the formula for electric field in the linear charge density. Okay. So, next linear charge density. What is the unit of linear charge density? Unit of charge is coulomb. Unit of length is meter. So, unit of linear charge density is coulomb per meter. Unit of linear charge density is coulomb per meter. Next one is surface charge density. Surface charge density. Surface charge density is what's the symbol? It will be used in the surface charge density, sigma, and charge by unit area. Charge by unit area. What's the unit of surface charge density? Coulomb. Unit is coulomb per meter square or coulomb meter per minus 2. So, sigma is equal to q by a. Unit is coulomb per meter square or coulomb meter per minus 2. So, that is a surface charge density, and sigma a is equal to dq. Sigma into dA is equal to dq. Sigma into dA is equal to dq. You substitute the formula for, substitute this value for the electric field formula. Q is equal to 1 by 4 pi epsilon naught integral of dq by r square. You substitute the dq value for this equation. So, 1 by 4 pi epsilon naught dq sigma into dA integration of sigma into dA by r square. This is the formula for electric field in the surface charge density. And then next one is surface charge density, that is a volume charge density. Volume charge density. Volume charge density is denoted as rho, charge per unit volume. Charge per unit volume. So, rho unit volume is equal to Q. So, rho V is equal to charge. So, rho into dV is equal to dQ. So, substitute the value for this dQ. Rho dV by r square. This is the electric field formula for volume charge density. Charge distribution is nothing but charge will be distributed on the whole over the system. That charge source is linearly, you have to use linear charge density formula. The charge surfaces will be in area portion, you have to mention the surface charge density. In the cubic surface, you have to mention the volume charge density. So, all are the term you will be find out the electric field formula for all the charge densities. Okay. Then go for the next one, that is electric field lines. Electric field lines. Electric field lines is nothing but is giving the visible representation of the electric field. Electric field ku diagrammatically line pandrathu per na electric field lines. So, electric field lines is it will clearly explain the what are the lines, what are the electric field will be between the two charges, easily find out. So, electric field lines, I will give the properties of the electric field lines. So properties of the electric field lines. So first one is start from positive charge and negative charge and end at negative charge. Suppose you consider the two charges, the electric field, that is the positive charge, that is the negative charge. Electric field start from the positive charge and then end at negative charge. That is electric field lines. So electric field lines is nothing but is giving the line for the electric field. So first point is electric field is always start from positive charge and end at negative charge. Suppose you have a unit charge, ஒரே charge நீங்கள் வச்சிருக்கீங்கன்னா, that is positive charge இருந்தால், the electric field start from the positive charge and end at infinity. Suppose you consider only one charge, that is a positive charge, the electric field start from that charge and end at infinity. Suppose you have to consider the negative charge, will be electric field is moves from infinity to that charge. Positive charge இருந்தால் அந்த சார்ஜ் வந்து இன்ஃபினிட்டியை நோக்கி போகும், நெகட்டிவ் சார்ஜாக இருந்தால் இன்ஃபினிட்டி டு தட் சார்ஜ். சரி, ஓகே. ஸோ டூ சார்ஜஸ் ஹேவ் டு கன்சிடர், தட் இஸ் எலக்ட்ரிக் ஃபீல்ட் இட் வில் பி மூவிங் பாசிட்டிவ் சார்ஜ் நெகட்டிவ் சார்ஜ். பாசிட்டிவ் சார்ஜாக இருந்துச்சுன்னா பாசிட்டிவ் சார்ஜ்லேருந்து இன்ஃபினிட்டி போகும், நெகட்டிவ் சார்ஜாக இருந்தால் இன்ஃபினிட்டிலேருந்து நெகட்டிவ் போகும். ஓகே. தென் தேர்ட் ஒன் இஸ் சப்போஸ் யூ டேக் அன் வெக்டார் லைன் ஃப்ரம் த எலக்ட்ரிக் ஃபீல்ட் லைன்ஸ். இப்போ ஒரு எலக்ட்ரிக் ஃபீல்ட் லைன்ஸ் எப்படி போகுதுன்னு வச்சுக்கோங்க. யூ டேக் சம் வெக்டார் டைரக்ஷன், the vector will be denote the tangential of the electric field. What's the meaning that? The vector, it will be denote the direction of the electric field. Electric field oda direction specify பண்றதா இந்த vector oda work. So the vector in the any point in the electric field lines will be easily explain the direction of the electric field. Okay. And third one, electric field is denser or rarer. What's the meaning the denser or rarer? எந்த இடத்துல electric field thick இருக்கும், எந்த இடத்துல வந்து lean இருக்கும். So electric field is denser. When is the electric field is denser? When is electric field is denser? They are having the larger magnitude. எந்த இடத்துல வந்து அதிகமான values இருக்கோ அந்த இடத்துல என்ன செய்யும்? It will be in a denser. So electric field is rarer. Electric field is rarer. Will be have a small magnitude. So electric field is denser, having the larger magnitude. Electric field is rarer, having the smaller magnitude. Smaller magnitude. So values வந்து கம்மியாக இருக்குது அப்படின்னா எலக்ட்ரிக் ஃபீல்டு வந்து கம்மியாக இருக்கும். தென் எலக்ட்ரிக் மேக்னிடியூட வேல்யூ ஜாஸ்தியாக இருக்குன்னா எலக்ட்ரிக் ஃபீல்ட் வேல்யூஸ் இஸ் வெரி டென்ஸ் வித் அரேஞ்ச்ட். ஸோ 4 points. First point is electric field is start from positive charge and end at negative charge. Suppose the positive charge, the electric field is moves positive to infinity. Suppose the electric charge is negative, the electric field is moves infinity to that charge, and electric field is denser, having the larger magnitude. Electric field is rarer, having the smaller magnitude, and you have to take the vector in the any one point of the electric field lines, it giving the direction of the electric field lines. And fifth point, electric field lines is never intersect with one another. What's the meaning that? One line is goes there, another one line is goes there. So electric field lines, suppose that two lines will be intersect with one another, you have to find out the dipole moment P vector. So P vector will be choose the two ways. ரெண்டு லைன் வந்து மீட் ஆகுது அப்படின்னா அந்த ரெண்டு நடுவில் இருக்கக்கூடிய P ஓட டைரக்ஷன் ரெண்டு சைட்லையும் போகணும். This is not possible. So electric field lines do not intersect with one another. What's the meaning that? Electric field lines do not intersect with one another. Intersect ஆகாது. ஏன் intersect ஆகாது? Intersect with one another. Suppose it will be intersect one another, one point will be taken out, that the point that the dipole moment having choose the two direction. This is not possible for moving the electric fields of lines. So electric field lines does not intersect with one another. And sixth point, number of electric field lines it will be directly proportional to the magnitude of charges. What's the meaning that? What is the magnitude of charges? Magnitude of charges means you've taken a one charge. Suppose you have to take one charge, that is positive charge. The electric field lines is moreover 8 lines. Moreover 6 or 8 lines. Okay, electric field lines is moreover 8 lines. Suppose you have to consider as moreover 8 lines. one charge. But suppose you have to consider the two Q charges. Magnitude is 2, the charge magnitude is 2, so giving the more and more electric lines. So this is called, so number of electric field lines is directly proportional to the magnitude of charges. Magnitude of charges means charge value பொறுத்து அதோட number of magnetic lines வந்து இருக்கும். So there are 6 points is very important for 5 mark questions. So you have to learn thoroughly, and as well as the electric field lines properties you should know thoroughly, easily understood the becoming topics. Okay, then next was a simple 2 mark, that is electric dipole. Electric dipole is nothing but two charges. You have to consider as the two charges, that is will be separated by the distance 2a. A and A. Two charges constitute a couple. Couple, what do you mean by couple? Two charges will to be, one pair of charges will be to form and a couple. So electric dipole, two pole situated at a distance 2a. So two charges are separated at a distance 2a, that is make an electric dipole. For example, HCl and oxygen, carbon dioxide, all are the examples for electric dipoles. Then electric dipoles, how will you find out? Electric dipole symbol is P vector. So Q, one of the charge Q, and the distance is A. You have to consider as a graph line 0 to 1, 2, 3, 4, 5. That side -1, -2, -3. So that is I vector, that is minus I cap. This is I cap, that is minus I cap. So Q A I cap, because Q A I cap minus Q A minus I cap. So Q A I cap minus Q A I cap. That is the difference between the two, because 2 will be opposite with one another. So Q A I cap minus Q A I cap. So you have to add Q A I cap plus Q A I cap. So 2Q A I cap. That is the dipole moment. Dipole moment is nothing but, so one of the charge and distance between the two charges. So product of dipole moment. How will you define the dipole moment? Dipole moment is defined as one of the charge and distance between the two charges, that is 2a. So that is the dipole moment. What is the unit of dipole moment? Unit of dipole moment, that is charge coulomb, that is the distance, that is meter. So unit of dipole moment is coulomb meter. Unit of dipole moment is coulomb meter. So what is meant by dipole? Two poles is constituted a couple to make an, separated by a distance 2a. And what are the examples? HCl, O2 and CO2, more and more examples for electric dipoles. And electric dipole moment is nothing but is the difference between the two moment between the two charges, that is QA I cap minus QA minus I cap. How will you put the minus I cap in this part? So minus I cap in the left side of your y axis, that is QA I cap plus QA